Hello everyone, and welcome to our next online workshop. And this is the part for today's workshop. Fairly simple part, nothing super complex. And straight away, I want to tell that, of course, this part will be available, the scan data of this part will be available for everyone as always. So you can take your hands on this part and try yourself. And I want to remind every one of you that we would like to have to involve you in discussions about this part or any other parts that you might want to find out how to reverse engineer, or you are struggling with something, and so on and so on. So basically you can write us an email to support@quicksurface.com, or at the same moment you can go to our Facebook group and make some polls there, and we can discuss everything in details and try to help you somehow. So yeah, it would be really nice to get some examples from you so we can figure out what kind of content to show you next time. Basically, we're doing this just to educate you and to gain more interest in all of you to reverse engineering tasks. So I guess we can start to actual job on this. I'm going to open just scan data, which is of course misaligned as always. And as always, we're starting with extracting some first primitives to align the scan data to coordinate system. So we're using the segments tool, and by dragging this slider, we can change the polygon selection. So I want to select the most top surface and use this as a primary plane. So I'm obviously selecting these regions, saying I want to fit their plane. We can take a look at analysis. Well, this is pretty rough part. It's casting and it's not like precision part. This is safety pin for some kind of huge pallet tracking system. So it's not super precise part, and that's why we are getting these weird deviations here and there. So it's not super perfect. And I guess at this moment we can just raise the analyzer to different deviation. So, okay, let's create our first plane and secondary features. I'm going to use lines from Sketch. So in this case, I'm going to use this edge border as one of them. Oh, the front one, I guess. So by holding Shift, you can drag around, select these slice points, and it automatically will fit your line or arc, depending what sort of point you have there. For example, if you select this, which is obviously arc, it will fit an arc there. So this way we can create the first line. After that, I'm going to create another line here, another line here. And from these two, I'm going to extract the middle line, which will sort of work as the x-axis. So once we have these several lines created, we can go to Align by Coordinate System, select the plane as primary feature. Okay, and then I'm going to select this line. Well, let's say this can be x-axis as well. And the third line to define the center point and direction. Let's click apply. Isometric. Looks perfect. So this is how we align such parts to coordinate system. Pretty simple and straightforward way. After that, we can hide all of this and start with extracting sketches to build our geometry. We'll go to 2D sketch. And considering this part isn't super perfect, I'm going to start with just one side of it. And during all this process of reverse engineering, I'm going to mostly stick to this side of part, and the other side will be mirrored. So I'm going to have good deviations here, and I guess not that good on that side. So let's go. Let's start with the overall outer shape. Same as previously, I was doing just by holding Shift and selecting sketch points. Now I'm putting lines here. This. Here. Also like that line, and actually this one isn't that good. So I'm going to edit manually, and by holding Control, you can see that there appears snapping icon. So I'm going to snap to this point, and another point I'm going to choose, let's say here. Probably I want to fit another line here. So later, by holding Control and dragging around the endpoints of our lines, the software automatically connects them. This, like this, and the last one. Okay, so we see that it's colored right now. That means it's a fully closed shape. So we can hit the extrude button and choose how far we want to extrude this. Typically for normal prismatic parts, we're using snapping option. So you can actually see how far to extrude your solid. But in this case, I'm not going to use that because we have sort of draft surfaces here and there. So I'm going just to extend it longer than I need, and I will just cut it away later. Okay, so we have created base geometry for this. We can take a look at Analyzer. Yes, and as I said, it's not super perfect part. As you can see here, it's matching really well. On that side, it's not that well anymore. And we can start to work from here. I guess in the first feature, I might, yeah, let's create this huge indent here. Basically, we see that we have another planar surface here inside. So we're going to extract primitives again, drag our slider until we see some nice segment here that we can select. Say these, hit the plane. Okay, it will be good right now. But as we are creating actually like, let's say, perfect CAD model, we want this plane to be perpendicular to YZ plane. So it would be same direction as the top plane we created previously. So we can come over and say we want it to be perpendicular to YZ. Okay, create. Done. And at this point, I'm coming to create 2D sketch. Drag it somewhere out of the fillet. For example, like this, create. Let's get another one here. Oh, well, actually, considering the geometry, we can try another approach. We can go to extract primitives. Let's select these points and say, I want to fit their slot. Not the perfect, but might be a good base to start from. Make it like this. Probably something like this might work pretty good. And actually, let's align it better, a bit smaller. Yeah, this looks like better. So like this. And of course, we need to make it bigger to complete the cutout. So we come over to line. Now start to put it here. Let's look at the centers of our points. Let's add dimension for this. Let's say one, for example. So now we can come over to him. And this one, at this point, we can tell this is tangent. And we can actually change some direction of it. Well, in this case, I'm going just to eyeball this direction, and later we'll take a look at the deviation analysis, what result we actually have there. So let's create the axis for mirroring. Like this line. Let's create it there, but from midpoint of this line. Yes. So select the mirror line, select the line that you want to mirror. Click mirror. Here, delete this one. This one we don't need those well. So let's close our profile like this. So now we can see change the color, so it means it's completely closed profile. Well, hit extrude. Here we can actually, we have two options. We can make it longer extrusion and later cut with this plane, or by holding Control, we can snap to this plane. So you can see right now it's snapped. And this will create the perfect plane that we fitted. But at this point, we see that this indent actually has some draft. So let's add it some draft, let's say in degrees, but we need it inversed. Then it's not enough, that's 20. much. Oh, maybe let's try with 20. So we can actually see here that the line starts to penetrate the mesh. Let's try with 18 probably. Currently, we can create this as a new solid. Let's hide this plane and we can come over to compare to and see that we actually have really good deviation in this draft surface. Same as on this side, on this side. So basically my eyeball lines were quite good. But if they wouldn't be, you can always easily come back to your sketch, click edit, and change direction of them to align them better. So we can come over, bring back our main body, and we have two options. You can click on main body and use cut from selected solid. Put result and set result. Or we can go back and edit the extrusion and simply select here cut function and get the same result, but saving some entries in our history list. So this is about this side, and probably we can add some fillets all around our part. Let's use tolerance option. That's, as I said, I'm going to focus on this side of part. So looks like something 3.5 millimeters. Okay, create and stay. Let's come over to the next one. This might be like 1.5 millimeters. Create and stay. Let's say this one 4.5 millimeters. So this way, one by one, you can add all your fillets with some nice deviation analysis feedback. Super simple and cool way because you don't have to make your fillet and go to compare tool and see have you actually nailed it or not. So you see this instantly. And one more here. Looks like something around 1 millimeter. Six. The next one. Two. The last one. 3.5. Okay, so we have created fillets for main body. After that, we can probably create these fillets right now. Hopefully. Like this, and let's get rid of the very last one. Let's start to fill it on this side. So again, 3.5. Create and stay. Probably we can go with this one right now. Okay, chemicals. Okay, and now like this one. Okay, perfect. So we can manage this side. And at this moment, we need to create this cutout right here. So let's create another sketch. As you can see, the surface is pretty uneven. So let's try to find something. Maybe this position looks quite good to me. So let's create it there. Let's enable clipping. Again, selecting the polygons, not polygons, but slice points. And on this side, actually have to align this edge to the actual edge of our solid, which is this one. Let's add line over here, and then holding control, let's connect them. Something like this. Yes, hit extrude. Make it longer. Actually, it might be easier for us to create this as a cutting tool. So let's go back to our sketch. Let's make complete profile out of it. Something like this. Okay. Now we can hide this one. And we need to create these separate surfaces. And these surfaces are again drafted. So we have like several options. We can hide the cutting part and obviously use this face to create a sketch. This way. Yeah, let's take a look at them both ways. So disable clipping, clip the orientation, add the body, and then focusing on this side. So let's put some line here, extend it. Yeah, let's extrude it. So as you can see, we have draft here, but if you have just one straight line, you won't be able to set draft. So you see the error message. Because for software, it's extremely difficult to define some direction for simple line. So what we can do here, so we can come over back to sketch, add another line at some angle, have the sketch like this, click extrude it again, and now we can actually draft it. Okay, so the 15 degrees looks like a pretty good draft for this surface here. Okay. After that, we can unhide the solid that we're going to use as a cutting tool. Select this extruded surface, come over to cut tab, use mirror function. Okay, accept this. Now we can hide our mesh, select all these entities, features, and trim them. Give it solid body. And at this point, we can take a look what's happening with our deviation. We can see on this side it's good. On the other side, as always, it's not that great. But as we're sticking to one side, so it's fine. Currently, we can go with different level, and let's say we want to add fillets to our cutting tool. Maybe let's say more than the tolerance option. We can align this. And train a cow looks like really good to me. Except this one. Okay, so our cutting tool now got fillets. Now we can unhide our main body. Now come over, select it. We use cut from solid to solid function. Oh, it doesn't work this way. Okay, we have some sort of error here. So let's try to get rid of this. We have two options: try to reduce our fillet, or we could go actually to pitch of this body, and let's change, let's say, angle of it closer to 90 degrees. And let's do it from here. Now let's try and create this once again. Okay, this looks good right now. Let's try. Again. Rather than just extend further past the more part. And as we have extended this too much, we can actually see that our trim didn't work properly because our trimming surfaces are too short. So we can go sketch up our trimming surfaces and let's just bend them like this. Okay, and then let's try again with our fillets. Oh, hi. So, okay. Let's try some different approach now. I just have this one. Okay, catch again. Oh, actually, let's skip this. Delete fill it from this. Get rid of trimming, this, cutting, this sketch as well. So let's try to fit the primitive here and see if this changes something or not in our life. So just as experiment, let's mirror this thing. This way. Let's see if this works. Okay, now this side works. Let's try to add fill away. Now, okay, ta-da. Okay, this worked. So it means sometimes these extruded adapted faces don't want to be too good friends with us, but it's always worth to try. We'll have to take a look at this issue, what happened here. So we have created this big indent here. After that, we can come over and probably let's fill it here. But this fillet guarantee will have some limitations considering we have sharp corner there. So let's just try and see what we can get here. Hmm, Failed to create bigger fillet. So in this case, I think I will leave this one for now, and we'll come back if we have more time left for this. There is a solution for this, but I want to show you how to actually complete the end parts of this part, so it's more or less finished. So again, coming to the left side of this part, come over to main tab, extract primitives, and I'm going to just go with fitting planes here. This one, create that one as well. we can come over, we can actually rotate them a bit so it's easier to understand how they're forming. Let's extend these planes. So they're larger than our solid. And we have good intersection of two of them. So select both of these planes. Let's go and trim them. We get single surface. Okay. And again, we're going to actually mirror this to the other side. Bring back our main body. Select all of this. Trim. That way one side, another side. We get the solid body. Perfect. Okay. And now we can come over and add some this last fillets on this side. Probably. Well, this one I will create randomly because as you can see, actually this part is casted part, and the tooling was from 2/2. And here we have casting mold connection line that was grinded somehow. So you can see actually it's like poking out of the surface quite a lot. But well, this time I guess we're not going to reverse this sort of defect, which wasn't like completely finished in the production of this part. So we're just going to create this more or less as it would be a perfect part. So that means I'm just going to add some random value to this fillet because I have nothing to align to. Let's say let's keep it like 12 millimeters. Create and stay, and we can select this complete edge and this complete edge, and we can make it well, currently due to some small sharp corner, it allows us to create 1.5 millimeters. Yeah, click OK. Let's take a look where might be the actual issue for this. So typically these fillets may fail. Yes, most likely because of this small sharp corner, because it will start to create some weird geometry. What means if I want to eliminate that, we would have to change this fillet probably. But during this session, I guess I'm not going to do that. In this case, this will work as a good example. And we have last two indents left here. So at this point, we have again several options. We can actually, let's do this. Let's fit another plane here. Let's say it's perpendicular to YZ. Okay. Create. Let's use this plane to create profile for our cutting tool. This scan surface is pretty rough here, so we will just imagine this cut ourselves this time. So let's do two lines. We can later create one on the top, one on the bottom, and just use Control and drag around the endpoints of line to connect them quickly. So like this. Let's extrude this. here we can actually disable probably that plane and use snapping function. So we can see where we want to snap it. So here it looks really good. And at this point, now we'll disable snapping because again, we have to create some draft here. So let's go with probably 45. Actually, 45 might be pretty close here. So let's click OK. Take a look at compare to. Oh, a smaller, tiny bit away. We can come over to this extrude and change it. Let's say for 50 degrees. Probably we have to go with them. Let's say it's 40. No, we're getting closer. But it should be good enough for this kind of part. So select the solid to CapTab, mirror. Okay, bring back our main body. Select that. Cut from selected solid. Select our cutting solid. And we have created these fillet indents. So let's slap some fillets over them. Here. Thank you. Let's say it'll be 1 millimeter fillet. Create and stay. Let's select the boundary. This one as well. Let's say it's going to be 1 millimeter fillet on this side as well. So this way we have created, reverse engineered this part, more or less. Compare tool shows, well, not that bad deviation in most parts. And as I said previously, this is like super up part. It's not precision part, and in this case, it's absolutely acceptable deviation. Costa, what do we have with questions at the moment?
To be honest, there are not many questions, which is good and bad in a way, but this is because you are doing really well the presentation. Most of the questions are, will this be available for later to be seen on YouTube? Yes, it will be. We'll share this. Also, you can join our Facebook where you can ask your questions if you struggle. What I really liked about the presentations is that you show the steps. Again, to repeat to the audience, the main idea is there one major fundamental step. First is alignment. You know, what Victor showed is you need to align your object before you start your reverse engineering. This is really important. And the next one is nothing is super complicated. You just take the pieces one by one, and this is how you end up your job. In the beginning, you always everything looks frustrated, but thanks to these step-by-step tutorials, you can just learn how to approach. You probably create a big volume and then you start chopping out of this. This is what Victor showed today. And then finally, you just finalize your object. What else I would like to point out is our ability for this online deviation analyzer. This is really cool. What I mean is that it really gives you the ability to decide what you want to do and how accurate. As Victor showed, do you really need to reproduce the problems of the object? No. You always need to think what is your goal, how you want to achieve what it's useful, and what do you need to do for manufacturing. Whichever scanner you take, it will never be perfect, and this is normal. And this is how you just need to do. So I do have several questions here in the Q&A session, Victor. So let's try to answer them one by one. How can I adjust the real scale after finishing the object? I don't know what you mean by real scale. This is in millimeters and you can export, or maybe I don't understand what you are. So please, if you give us more details about these questions, we will try to answer. Victor, do you see the questions in, or you prefer me to read it?
I'm currently reading the chat session, so you can continue with Q&A. I will just hop there in a couple of seconds.
There is a question about the Rhino plugin. Is it similar to the standalone? Well, over the years, I always try to explain this. Quick Surface is a standalone, which means you get Windows, you install, you use it, you export. We have two plugins. One is for Rhino and one is for SolidWorks. The Rhino plugin allows you to extract some features, but then the actual modeling you do in Rhino. What it means that what Victor showed today is not our world. In Rhino plugin, you can extract, for example, planes. You can extract a cube, but then when it comes to actual Boolean operations or filleting, everything is in the hands in Rhino. So then you need to contact Rhino for support. You need to learn Rhino, and you need to get this software, how you can use this Rhino itself. So that's the difference. In the same way, we have the plugin for SolidWorks, which is designed for SolidWorks users. Again, you can extract the valuable information, but the actual Boolean operations and the cut things you can do with the native tools in SolidWorks. So this is the biggest difference. I'm going to the... Okay. Just when it starts, can I get the email ID to send the request? I don't understand your questions, but if you have anything to contact us, just send an email to support@quicksurface.com and we'll be happy to support you at any moment. Can you show how you get a usable step STL file out of the created body? Well, Victor, if you just show, you just press on export. You can go to, export model. And then in the export model, you can export as a step or IGES file format. And also, when you do the 2D sketching, you can export as a DXF drawings that you can import somewhere and you can use it. I hope this answers your questions, but if you want, you can type it again.
Yeah, so basically this what we did here, we reverse engineered this part, so this is a solid body, which means you can export this as a step or IGES. So step or IGES is just a file format that is handling all of this, all the geometry. So basically you can get all of that, and this is the step that is required typically by all the customers that want somebody to do reverse engineering tasks.
Yes. So another question is, after finishing the object, it has the scanner measurements. If you need to refine these measurements, what do you do? This is exactly what we show. It's a parametric modeler, so you can always, on the left side, you can see the feature tree. You can go and you can edit a sketch, or you can change the dimensions, and then this is what it will, you just edit, and then it will recreate the object in the way that it's been by design, not by the scanner. That's the
Well,
so
yeah,
here.
basically, if we have some good reference dimensions for something of this, I don't know, for example, you know exactly what angle should be here, then you can come over and change this angle or just do this while you are, for example, creating these sketches. Of course, if you, for example, set this to like 70 degrees or something, and for example, I don't know, this is like a horizontal line, so you can see this line right now deviates from our mesh. It will start recalculating, but again, if, for example, there will be insufficient cutting planes or something, it will result in some errors. In this case, it worked out, but as previously I was showing with this cutting tool, when my extruded surfaces were not long enough, it wasn't able to retrim the modified sketch that was extruded. So basically, you have quite a lot of flexibility. Just you have to understand what actually you need from this and what measurements. Pretty often I have seen the comments in some groups that people can't actually import the correct scale of their parts, and they're asking how can they rescale the scan data because somehow it came out from their scanning software in wrong dimensions or something. I don't know how this works, but I typically haven't met such conditions, but well, probably there is something. And if you want to rescale your scan data, you can always do that. And in scan data tab, you have a scale
Yeah.
function for your scans. So this can be achieved pretty easily. But of course, it depends on case.
Now we have a question. Since you said we are using a SolidWorks extension, no, we are not using SolidWorks extension. We have a plugin that works inside the SolidWorks, which actually extends the capabilities of SolidWorks. That when you install our plugin inside the SolidWorks, it will allow SolidWorks to be able to load a huge amount of meshes, such as something between 60 to 100 millions of triangles. Our plugin allows SolidWorks to be able to use the scan data, so you can design around the scan data and then achieve your goal. Though that's the difference. Do I have to purchase this plugin to SolidWorks? If you visit our quicksurface.com, you'll find our offerings. We have this standalone application, and then we have the plugin for SolidWorks. There are a lot of videos about how this plugin works, but if you need additional information, contact us, and we're happy to set up a personal demonstration for you for how this works. I hope this answers your questions about the plugin in SolidWorks. I'll just mark it.
Well, there is just one thing to notice about plugin. Plugin isn't the same as this standalone software. So in standalone software, we have much more specially designed tools to work with meshes. In SolidWorks, yes, you have as well, you have some kind of, let's say, you can create new freeforms, you can fit surfaces, you can make sketches according to slices of your mesh and so on and so on. Of course, fit primitives and things like that. But you will notice there is a bit smaller amount of these special tools than we have here. But still, it depends what you are working on. Sometimes for people that who are using the SolidWorks, they're doing mostly prismatic parts or reverse engineering some specific machine parts or something. It's not bad. It's pretty good actually, and for people that are trying to design something based on scan data, I would say SolidWorks have quite a lot of flexible tools. So basically, with this plugin, you can allow SolidWorks to work with scan data properly, extract necessary geometries from these sketches, and so on, and then use all the advanced tools of SolidWorks. Then they have huge like amount of these tools with including the surfacing tools and solid tools, and well, this gives you a lot of flexibility for designing, of course. And at the same moment, you can see the deviation to the scan data around which you are designing, and you can pretty easily create like mating surfaces to the scan data.
Okay, we have a lot of other questions. It's about the Fusion 360. At the moment, we don't have any plugin for Fusion 360. We haven't said no, but I hope we probably may have in the future, but we don't have the plans right now. So this is about the Fusion 360. Regarding the inventor, we use the technology which is called COM when you communicate, so it should work. Even if it works in 2023, it should work with the Inventor 2026. From our test that we did, it doesn't show any issues, so it should be working okay. If you have any problems with it, just let us know. But you can just download, install a trial, and try to communicate with the Inventor 2026. If there are any issues, just let us know. When you want to print, how we want to save, it really depends. You have two options. You can export a step file format, which is a purely surfaced model, and then rely on the printer software to do the tessellation and the decision how to print the object. But also you can export as an STL file and then send it to any printer. The common file formats are step and STL meshes for if you want to export for printing. When you run the auto freeform, are there any guideline to follow, like amount of mesh, holes removed? Yes. When you do auto freeform, actually, Victor, can you just hide the cut model? And this is the part. And what happens always is people just get really lazy and they just do the auto freeform. Can you run the auto freeform so we can see the results? So in this case, you probably say, I want the highest possible, I don't know, just put it to fine. And then you say feature details, people want the highest, and you press go, and we see what's going to happen. So this is the auto freeform. It's the amazing tool. It takes a couple of seconds. We are really proud of this, but if you press OK now, this is what you get. So now what are the limitations and what you can do with this? How the auto freeform works, it just wraps around the surface if you hide the mesh so people can see the... So this is what you get, and it's a cut model. So then people may say, why Victor spend so much time to demonstrate this cut and trim and so on? Well, because what you see on the screen is useless. It says useless in terms of geometry because it just wraps the mesh around and it's a step. But still, this is not good enough for you. It's not parametric. It's not perfect plane. It captures all the imperfections of the scanner. So this is, you can imagine if you are in a kitchen, you take a kitchen foil and you wrap around the object, this is what you get. Although it has amazing applications, which you can see in our other workshops or videos, it can be used for the freeforms when you have castings or organic shapes. We don't recommend to use this method in the objects like this one, because the next step, I really don't know what you can do. You don't have any control on the fillets. The fillets are just not good enough. So you can
There
give
is
it
no
a try.
fillet.
This is what you get of auto freeform. So yes, it's a step file, but is it useful? it's really in your hands. If it works for your application, then it's fine. I hope this answers your questions, but if you have more about automatic surfacing, let us know and we'll be happy to answer.
Yeah, one more thing. So here is our reverse engineered part that I saved as STL, exported it, and then brought it back as a scan data. So at this moment, let's just move it and see the actual difference. So the same would go to auto freeform. So in one case, you get all the imperfections of scan data, well, all these ripples and everything, all the noise and all the defects. On the other side, you got like absolutely clean part with nice planar surfaces and everything. So this is up to you. For what are you going to use this? Of course, well, you can use this auto freeform if you just need to roughly copy some part and you don't really care about the surface quality. You just need some approximate that would work, I don't know, as some cover for something, and you don't care about this surface quality, then you can do this. But for manufacturing purposes, or if you want to do this as a reverse engineering job for somebody, these people won't be happy with this result. We are getting quite a lot of emails where people are asking, what can I do to improve it? How can I change the fillet here or there? Or how can I get the crisp corners? Well, you can't, just because it's wrapping around the scan data. And that's all what it does. So it's not a great approach for like reverse engineering prismatic parts or some more precise parts.
All right. Any other questions? Just check. Okay. Yeah, we're at the end of our time. So thank you very much for everyone who attended this workshop. I appreciate the whole activities and all the questions that you had. I hope we managed to answer most of them, but again, if you have more questions anytime, just send an email to support@quicksurface.com. Victor's and Alex are our team, and they will do our best to answer as quickly as possible. And I appreciate, again, as Victor said, if you have any ideas, send us your parts, whether they're freeform, more complex, or more challenging, and we'll do our best to make our next workshop with your parts.
Yes, that definitely would be great to get some ideas from you.
Okay, this is the end of the webinar, and now I'm going to stop it. Thank you. Thank you very much, and have a good rest of the day. Thank you.
Yeah, see you next time. Bye.